pass them over, and we'll come on to that stuff. Ooh, who's Scott's buddy? Amazing. Fun fact, my husband, who's a big nerd, told me that they may have found another planet in our solar system. I don't know where it is. It's like way out there, but it's the size of Saturn. But they're still collecting data on it. So that's cool, people. Pluto's out. You guys in, okay? Before I also forget, these individuals need to get the syllabus thing signed and the lab safety thing signed on my website. I checked it at like 10, so please have your parents do that for you all tonight. Okay, so let's just do a baby intro to chemistry. Basically what it is, the 5 branches of chemistry, and then we're going to get into some safety information again to talk about properties of chemicals. So this information is found mostly in chapter 1 of your textbook, and some of it's just definitions. And if you pay really good attention, take good notes, reading guide 1 and 2 will be very easy. We're going to start with this information first. So what is chemistry? It's a study of matter, which is why we talked about matter so intently earlier, and how it changes. And that sounds so easy, right? It sounds fairly simple. But guess what? Matter can change in like, I don't know, a billion different ways. And you can change it with lots of different methods. You can change it by addition of heat. You can do it by changing, remember delta means change, changing pH of it. You can change the states of matter, etc. Right? We're going to learn all kinds of different ways to change matter. And we're going to observe differences from the matter as we change it. So this little cartoon has the guy selling water, but he's not actually selling water. He's got hydrogen, and oxygen, because that's what water is made of. It's composed of 2 atoms of hydrogen and 1 atom of oxygen. So we're going to talk about composition of matter, and then you can see here physical change, chemical change. Well, this physical change is just liquid water going to solid, right? So it's a physical change because there's no compositional changes. It's just still water, H2O, still water, H2O. The chemical formula did not change. But down here, we have Mickey Mouse, right? Mickey Mouse is H2O. And it changed to, does anybody know the formula for this? Hydrogen peroxide?
H2O2.
Yeah, and you can actually figure it out from the picture too, right? H2O2. And so that hydrogen peroxide is what we actually don't want that in our body. We have catalase, an enzyme in our body that if you did in biology, a liver enzyme lab, catalase bubbles up the hydrogen peroxide and gets rid of it. That's when we pour hydrogen peroxide on a cut, what happens? It burns. And it bubbles up, kind of fizzes up. It's because it's being decomposed. Anyway, so this is a chemical change because we have 2 different formulas indicating a chemical compositional change. Okay, so there are 5 areas of chemistry. I think some of them will be very familiar to you. So organic chemistry is something you mentioned probably a little bit in your biochemistry unit in biology, and the basic part of organic is just going to indicate that it has carbon in it. And so what's a sweet substance that has carbon in it? Glucose, right? Formula C6H12. O6. I go, whew. So that's our organic molecule of glucose. We can go to sucrose and dextrose and fructose and all kinds of different oses because they're all carbohydrates. They all have tons and tons of carbon. So you can see that's going to be one thing we'll study this year. In organic chemistry, you can probably denote what that one might be. So I left it blank for you based off the prefix in. Stuff that doesn't have carbon, right? Just don't have carbon, okay? So can you think of any chemical, any compound, anything you can think of that does not have carbon? Don't get too crazy. Some of you guys have it on your desk. H2O. So H2O isn't a good example. What do you put on your french fries?
Sodium chloride.
Okay, ketchup, but sodium chloride. There's tons of salt, table salt, sodium chloride in your ketchup. There's some examples like, let's see here, what else would maybe you, oh, ozone, like O3, ozone, you probably heard of. Oxygen, we can keep going, right? Nitrogen, hydrogen. These are all molecules. They don't have carbon in them, so those are some good examples of inorganic chemicals. Third category, biochemistry. So that's just going to be related to life. It's going to usually involve a lot of processes that occur inside the body. So one example, photosynthesis. That's a good example because there's multiple reactions that occur with light reactions and dark reactions. Lots of chemical changes going on, making all kinds of different intermediates before they make glucose, or vice versa, making ATP in cellular respiration. So anything that happens in the body is going to occur by a mechanism, and that mechanism is just a series of chemical reactions. So there are many examples. Reactions are Rxn. So you're familiar with some of these, but this is one we'll touch on some. This is one of my favorite things to talk about, but we have to have a whole course just on biochemistry. It's a big topic. Okay, thumbs up when you're good here. All right, pretty easy stuff so far. Analytical and physical chemistry are our last two branches. Analytical chemistry sounds kind of like you're analyzing something, and the thing you're analyzing is the composition of the matter. And a machine that can do that is called a mass spectra. This is kind of like a piece of equipment. It's a tool that we use because matter is so tiny, we can't get on its level. We got to bring it up to our level. And we have to use machines to give us some sort of information about that. So this is kind of hard to see, but you might be able to tell they're like pieces. That's like a black dot with 3 white dots around it. Well, that's 2 black dots with 5 white dots around it. And so it shows you the breakdown of the chemical composition, and it has a lot of math in it. It has a lot of calculations in it. It's pretty fun if that's your thing. This one has a lot of titrations in it. So it's kind of intimidating sometimes, but that's one thing we'll get into a little bit. We'll touch all of these a little bit. Last one is physical chemistry, and it's talking about kind of more the physical traits of the properties of matter and how it changes in terms of, usually how it changes in terms of thermochemistry or reaction rates. Thermochemistry probably sounds like something with thermal, which is going to be heat, and we can change matter by adding or taking away heat or energy. And then the second one, reaction rates, is just basically how fast does a reaction happen. Have we seen activation energy before or heard of activation energy? Maybe have you heard of speeding up chemical reactions? What biomolecule in the body does that? Enzymes. And enzymes are an example of, which of the 4? They are catalysts. So enzymes are catalysts, which are proteins, right? Protein is kind of the big category. These are 2 pseudonyms for a protein, for an enzyme or a catalyst, which are considered a protein. What they do is, instead of making these poor reactants have to climb this big hill to put forth all that energy just so they can come over here to make products, what an enzyme or catalyst does, they speed up a chemical reaction by lowering the activation energy. Means the hill goes down to like here, and then they still continue over, to their products that they're forming. So the way an enzyme or catalyst speeds up a chemical reaction, instead of making it go all the way up this big hill, which takes forever, they go this little hill, and it's faster. That's actually what speeding up chemical reactions means, and it's by lowering the activation energy. EA is activation energy. So now, you already knew that, but now you know more, okay? So that's physical chemistry, and we'll get into actually all of those throughout the year. Questions so far? Pretty easy stuff so far. Okay, so here's what we're going to do now. I'm going to give you a brief background of the assignment you're going to do. You're going to do it in your lab groups, and then we'll move and we'll do it, okay? So let me show you how to avoid an explosion. Everybody's first question in chemistry. And you might need a piece of paper, you might not. You'll be working on the laptop some. You guys remember your numbers? Did I give you yesterday's? Yeah. It's a number seat you're in, the question you found the syllabus scavenger hunt. So your goal is that you're going to be organizing a chemical safety closet based off the chemicals that you choose. We're going to be exploring the properties, how to be safe about them, and why things should be stored the way they're stored, why we should handle chemicals the way we handle them. So you're a safety officer in a factory. The OSHA, who's ever heard of OSHA? Okay, OSHA inspectors, they come and they rip you a new one for having things together that you shouldn't. I have been yelled at before by OSHA for not storing things 100% safe. So we're going to make sure we satisfy this OSHA officer who's coming to inspect us. So we need to provide them with a chemical inventory, which is just a list of chemicals, and a closet diagram on how we're safely storing them with an explanation of why things are where they are, like why are acids and bases not next to each other, or why is this thing that's really flammable not next to this thing that's really flammable? No, why is this thing that's really flammable not next to something that sparks really easily? So you want to try to explain it in terms of logic, right? So what you're going to, this is kind of a setup, right? What you're going to make is a product, which is a diagram, and it can be, you can make like a trifold with some paper, you can just draw it on a piece of paper, you can make an electronic version, it does not matter to me. Your group will decide, you guys will communicate together what you want to do. You're going to tell me first, you're going to choose 10 chemicals, 2 per category, so you've got lots and lots and lots of choices, and you're going to do a little background research on them and how, their safety precautions. After you choose your 10 chemicals, then you're going to talk about the reactivity, you're going to look at their SDSs, which are safety data sheets, and their symbols. Some of those look like these safety symbols. I think you're probably somewhat familiar with. Things like this. Maybe you've seen someplace. You'll see some today, okay? You'll do a little bit of background information, background research, and then you'll draw your diagram. With that, though, one person, or maybe all of you guys agree, you're going to look up one real-life accident that occurred that was due to some sort of unsafe handling of chemicals. It could be like people transporting them. It could have been like in a high school. You guys, maybe did you hear that somebody at, was it Central, got caught on fire in a chemistry lab, like last semester? Northwest, and they got severely burned. Like, it was kind of crazy. And I did the same demo. It was a pumpkin, and you put flammable substances in there, and you squirt ethanol on it, and we caught it on fire, and we just kept catching on fire. We played with it for about 30 minutes. But we were all fine. So you can talk about anything that's of interest to you. There's plenty of examples out there. So that's kind of the concluding part of it, okay? So quick reminder, what are you making? What are the deliverables, things I need from you, okay? Chemical inventory list, which category they came from. The diagram of how they're supposed to be arranged with some explanations of why things are where they are, and then a paragraph about your real life accident. Clear? All of this is on my website, okay? Let me show you where it is before you leave me. Under Unit 1, how to avoid a safety or how to avoid an explosion. That's the activity. And then if you want some more information, there's a reading on chemical or chem matters. But those are the only 2 resources I have on here. Under the safety document up here, there's some other links that will be really good resources for helping you find information you might need, okay? All right, so what are your lab groups? They are here. I always make your lab groups at least the first time so that I know who's in what group, okay? There it is, okay. So lab station 1 is the first lab station. Lab station 2 is adjoining it. Lab station 3 is in the back. Lab station 4 is adjoining it. Lab station 5 is in the middle back. Lab station 6 and 7 are together. 8 and 9 are together, and 10 right here in front. You good? Okay, you can go to your lab station first and start exploring, or you can grab your laptop. Is this the wrong class? This is right class, right? Oh yeah, I will scroll down. You guys will grab your laptop, okay? So you can do the laptop now or laptop after you get back to your group. Take a minute, get your laptop and get to your group. Go for it. Alright, I'll come around and answer questions, but acquaint yourself with your group members. And if you guys, after you get kind of at your lab station, and you realize you want more space or you want a seat, this lab station actually has no way for you. You can switch here, you can switch the seats depending on what kind of space you need with your group.